We're Team Posture Perfect, and we help get you to your right angle. So the problem we're tackling is improper posture, which affects over 85% of the world's population. Worsening posture can lead to both neck pain and back pain, and it has also been proven to lower your self-esteem. So what we've done is we've created a biofeedback device that monitors the angles and the posture of a user and provides feedback via vibration whenever a user is slouching or not in their anatomically neutral position. The way we're doing this is by utilizing 3 sensors, an accelerometer and a gyroscope to track the position of the user, and an EMG sensor to track the muscle activity of the trapezius muscle on the back.
As discussed earlier, we'll put the device on the trapezius muscle, and so we want to put the ground at the C7 right here because it's a good place that's palpable, and then the other part will go right here to measure the trapezius muscle. Jeffrey's going to create a profile, and he's going to input the file name for this profile, and then he'll input his name, age, gender, height, weight, how many hours per day does he typically spend sitting, and what is his back pain rating. And lastly, he can choose his tolerance setting. There's beginner, intermediate, expert. And now he's finished creating his profile.
Now Jeffrey's going to jump into the calibration session.
Place yourself in a severe slouching position. Next, you will remain in this position for 5 seconds. The countdown will begin shortly.
So first, the program will record his poor posture using the accelerometer and gyroscope sensors.
Stand or sit up as straight as you can, like seen in the image.
And now the program will record him in his perfect posture. And then he can choose to recalibrate or to select finished. Now Jeffrey will begin his posture sensing session. And now our sensors are monitoring the 3 different angles and also the voltage produced by the activity of the trapezius muscle. So right now Jeffrey's in perfect posture, the device is not alerting him, but as soon as he begins to slouch for 2 seconds consecutively, we see that on the front panel the indicator lights up, alerting him that he is in poor posture, and the box is vibrating, alerting him that he needs to correct his posture, and once he does, the indicator turns off, and so does the vibrational feedback. And he can also do this if he tilts to the right. So after 2 seconds, the indicator turns on, and there is vibration on his back, and now he corrects, and he's good to go. On the home screen, the user can also select to view the posture stretches, which we recommend they do to help them better their posture. We've included images as well as audio step-by-step instructions that they can listen to and follow, and we hope that they continue to do this over time and see results after several times of using this.
Lie prone on the floor.
We're able to determine bad posture by using an algorithm that makes use of an accelerometer's values in G and a gyroscope's values in degrees per second. For the accelerometer, we try to determine the user's position by essentially double integrating the linear acceleration over time. For the gyroscope, the values in degrees per second are essentially multiplied by the period intervals to determine the user's position over time. By carrying out some trigonometry, we're finally able to get the angular position for a user at a specific period. The EMG sensor is something that we're particularly proud of because with it we're able to measure isometric contractions, which are clinically relevant because they could tell a physical therapist what strain is being put on what particular muscles when the user is in poor posture. Another thing that we're particularly proud of is a Bluetooth sensor that we're able to incorporate into our device because this gives our device the functionality of the user being able to walk away from the user interface and still have the device consistently monitoring and interpreting the data. So for a college student who's walking across on campus and has the device at their back, they might be able to be alerted to their poor posture via a vibrational signal.